Ospf, or the Open Shortest Path First Routing Protocol. What is an Ospf? Ospf is a link state routing protocol designed to scale efficiently to support larger networks. It uses the Dijkstra algorithm to determine the shortest path. Ospf uses cost as its metric, which is computed based on the bandwidth of the link. Ospf advertises the status of directly connected links using link state advertisement instead of advertising the distance to connected networks. Advantages of Ospf. Ospf has fast convergence. It is a classless protocol and thus supports VLSM, or variable length subnet masking. Ospf uses the concept of areas to implement hierarchical routing. Ospf uses a link state algorithm, and therefore the Ospf convergence diameter is wider compared to the diameter of the RIP. Ospf transport only the new or updated values instead of sending the entire code.
Here is an example of a network topology where we use the Ospf to configure it, and these are its network addresses. First, we're going to configure the IP addresses of each interface, example here in router 5. In the CLI, type enable to enter the privileged exit mode, and then type configure terminal to enter the global configuration mode. Next, type interface followed by the interface type, which is the fast Ethernet 0/0. After that, type IP address followed by the IP address of the interface. And then its subnet mask. Next, type no shutdown to enable the port. The next thing we do is to configure the IP address of the serial port in the router 5. Do that, type interface in the global configuration mode, followed by the serial 0/0, which is the interface type and port. Then, type IP address space the IP address of the interface type, followed by the subnet mask. Type no shutdown to enable the port. Since the port is a PCA type, set the clock rate. To set the clock rate, type clock rate space the value of your clock rate. Another example of configuring your IP address of the interface here in router 4. First thing you do, type enable, then configure terminal to enter the global configuration mode. Next, type interface, followed by the interface type and interface port, which is the serial 0/0. Next, type IP address, followed by the IP address of the interface type, and then its subnet mask. After that, type no shutdown. We don't need to set the clock rate because it is not a DC type port. Then, we configure the IP address of the serial 0/1 in the same router. To do that, type interface, followed with the serial 0/1, which is the interface type and port. Then, type IP address, followed with IP address of serial 0/1, and its subnet mask. After that, type no shutdown to enable the port. Set the clock rate because it is a DC type port. Do the same configuration step to configure all the IP addresses of the interface in our routers. After assigning all the IP addresses in our interface, we will going to assign the IP address of our computers who are connected in our router. Sample here in router 5. We will set the IP address of our computer and then its subnet mask and its default gateway. Its default gateway is the IP address of the fast Ethernet. Next, we will assign the IP address of the computer we're connected to router 8. Same as the computer in router 5, the default gateway is the IP address of its fast Ethernet. Also here in the computer we're connected to router 7. We will type its IP address, its subnet mask, and its default gateway. Same as the other computer, the default gateway is the IP address of the fast Ethernet. After assigning the IP addresses of our interfaces and computers, we're now going to configure our routers using the Ospf routing protocol. Sample here in router 5. First type enable, then configure terminal. Next, type router space Ospf space the process ID. Then type network space the network addresses which is directly connected to the router 5 space its wildcard mask space type area and its area ID. After typing all the networks, we're going to type fault information originate. This command is used so that quad 0 route will be propagated. Another example of configuring the Ospf routing protocol here in router 4. First type enable, then configure terminal. Next, router space Ospf and then its router ID. Next, type network space the network address of the network which is directly connected to router 4 space its wildcard mask space type area and its area ID. Next, type default information originate. Do the same Ospf configuration to the other routers in our network topology. After configuring all the routers with Ospf protocol, now we were going to set the passwords in our line VTY, enable, and line console. To do that example here in router 8, first type enable, and then configure terminal. Next, type line console space 0 and then type password and your password to your line console. And then type login. Go back to the global configuration mode. Next, we're going to set the line VTY0 space force password. To do that, type line VTY space 0 space 4 and then type password space its password and then type login. Next, we're going to put a password in our enable. To do that, type enable space secret space its password. Type do right so that our configuration will be saved. Do the same steps in other routers so that we can remotely access to other routers.
Now, we're going to test the communication between the computers and the routers. Example here in router 3. Go to desktop and then the command prompt. We're going to telnet the PC1 by typing ping space the IP address of our PC1, which is the 192.168.10.2. As you can see, there's a reply from the PC1. At this point, we are connected with PC1. And now, we're going to telnet to router 5 using the PC3. To do that, type telnet space the IP address of serial 0/0, which is the 192.168.2.5. Since we put the password in our line console, we'll put its password. Then type enable. Type the password of the enable. As you can see, we can now remotely access the router 5 using the computer 3. And that is how to configure the Ospf routing protocol. I hope this video helps you in your configuration using the Ospf routing protocol. This is William Vihoyno, a BSID 3B student. Thank you for watching.